Okay, in this video, I'd like to run through the test criteria or the expectations for the test on Friday, as well as run through some more optimization problems. These optimization problems will come from a worksheet generator instead of our textbook. So they look a little bit different, but the process is going to be essentially the same. Now, on the test Friday, I had mentioned this before, but I'll clarify again. There are 13 questions of varying difficulty, and you'll choose 6 to be graded. You can complete as many as you'd like in the 90-minute time frame, but I'm going to ask that you choose 6 of them for me to score. Each question is worth between 12 and 24 points, and so the combination of problems that you attempt should sum to at least 100 points. If they don't, well, you won't have the opportunity to earn 100 out of 100, but that may be a good strategy for you if you're concerned about the work that goes into a challenging question. And for every problem, regardless of its point value, there are essentially 4 components that I'm looking for when I score them. Number 1, the first component that I'm looking for is that you've identified an objective function. And you should recall that the objective function, when we're reading the word problems, they're usually associated with phrases like maximum, minimum, most, least, etc. So when we see those phrases, we tend to find our objective function around there. And part of what I'm looking for is that you've written the objective function correctly for the problem and that you've also rewritten it in terms of our constraint functions. Now, the constraint functions are the second item that I'm going to be looking for when I'm scoring each problem. And remember, the constraints are essentially our limiting factors, what sort of restrictions that we face in this environment. And one of our goals with our constraint functions is to rewrite each constraint with a single variable. Whether it's the same variable that the constraint was written in or something different, if we can rewrite them as an expression or function of a single variable, then when we rewrite our objective function, then it too will be written in terms of a single variable, and it'll be much easier to optimize. Now, during the process of optimization, you'll need first and second derivatives. So I'll be checking to make sure that you've calculated your first derivative appropriately and your second derivative appropriately as needed. I will note that the second derivative may not be necessary in some cases, or you may choose not to use the second derivative as long as you use a complete first derivative test. So we get so comfortable with identifying maximum points and minimum points by finding where the first derivative is 0 and the second derivative is either positive or negative. That helps us identify maximum and minimum points. But you might also recall that during the first derivative test, if I had a number line with several critical points identified, we can investigate in between those critical points and find where the first derivative is positive or negative or say positive again. And identifying the regions or ranges or intervals in which they're positive or negative will lead us to identifying a maximum point and sometimes a minimum point. So when we switch from a positive first derivative to a negative first derivative, as long as this critical point had a derivative equal to 0, then we found ourselves a maximum point. And when we switch from negative to positive, we found ourselves a minimum point. So in place of the second derivative calculation, if it would be easier to complete a first derivative test with test points, that would be fine as well. Now, the fourth part of every problem is the final answer. I want a brief verbal explanation. Now, when I say the word verbal, I don't mean that you have to actually say it out loud. I mean just a written response that explains what you found. We haven't been doing that a lot in the video notes that I've been putting together this past week, so in this series of examples, I think I'll try to do a better job of that. What I really like to see is that you clearly understand what the result is, what the math is telling us, and how you can verify or confirm that the result that you found is the correct one. So on a typical 12-point problem, if the problem is identified as a 12-pointer, and you'll know that as you read through the problems on the test, Point values are generally pretty even. The amount of work that goes into the objective, constraint, derivatives, and rewriting your final answer are pretty well evenly distributed. So I wouldn't be surprised if I subdivide a low point value question in such a way that each one is worth the same amount. But as we get into those more challenging problems, the breakdown tends to look something like this. Now this isn't specifically what every 24-pointer would look like, but I just want you to see how the importance kind of shifts here. The objective functions, I think, would be a little bit more difficult, as well as the constraint functions, a little bit more difficult to identify and utilize. So instead of being worth 3 out of 12, we'll say that this is going to be 6 out of 24. So there's still roughly 25% of your score coming from that component. As far as the write-up goes, I don't think there's any real difference between the write-up for your answer for a simple problem or a difficult problem. You're simply identifying what your answer to the question is. So no change in difficulty there. So I'm going to retain the 3-point value for that particular set. But where the challenging problems become more difficult, it's in calculating our first and second derivatives and interpreting the first and second derivatives. So you'll see the weight of that question jump significantly. Now, there is one or two problem styles that I've seen in that the derivatives tend to be, or could possibly be misleading, and it takes some careful interpretation there. So if I choose a problem like that, I may even weight the problems this way, where I give 4, 4, 3 to this guy, but maybe as much as 13 points to the computation of your first and second derivative and interpreting them. In the review document that I provide in class on Monday, I hope to have point values assigned to each practice problem. We definitely won't have time to complete all of those, and I wouldn't necessarily expect you to complete all of them before the test on Friday, but at least you can read through them and see what I would deem as a high point value question and a lower point value question. Now, for the rest of this video, I'm going to work through these optimization problems, and in a slightly different way, I'm going to actually do this silently. I'm not going to record my walkthrough or my discussion for each of these solutions. I'll record the steps as I work through them, but I'm not going to provide an explanation. I think that reading through the problem and watching the results display on the screen and having you think about what I'm doing or recognizing the work that I'm putting into it, I think that's a good studying habit to get into for this type of work. Since I'm going to expect you to do all of this on your own later this week, I do think that watching and interpreting the work that I've done is going to give you an opportunity to make yourself better. If there are any points along the way that you have a question about what I'm doing, take note of the timestamp in the video and send me a message, and I'll respond back to you with a further explanation, or we can talk about it in class next time. So with that being said, I'm going to shut off my microphone now and work through this series of problems. Thanks for watching.